Hello world, welcome back to my YouTube channel. Today we'll be solving the merge to sorted linked lists problem. It's a classic and it's a foundational technique for most other Leetcode problems you'll see during an interview. So let's just dive right in. It's pretty straightforward. You're just given two linked lists and they're sorted and you basically have to combine them in place, right? You can't just make a new linked list and copy values back and forth. So it's pretty straightforward. If you have like a list of 1, 2, 4 and a list of 1, 3, 4, you would have an output of lists 1, 1, 2, 3, 4, 4. And of course, the tricky part is, of course, combining them in a way such that you have them in place and are not creating any new lists. So there's two ways to do it, a recursive way and a iterative way, and I'll show you guys both. So let's get to it. I'm going to start off with the recursive way first. So the best way to think about it is that we need to go through each list, grab the lowest value from it, and add it to our new list. And then from there, we can return a result, right? And because we're doing it a recursive way, we need to start with the base cases first and then add the recursions layer, right? So if the first list is empty, then we know that the result is just going to be the second list. Similarly, if the second list is empty, then we know the result is just going to be the first list, right? And now the recursive part is basically where we grab the comparison. We grab the values at each list, wherever we are in them, to that val, and we basically say that, okay, if the list 1 val is like less than, which means it must come first before the list 2 value, then we just take the current value in list 1, and we say, okay, the value after it is going to be whatever the merging of the remaining of the two lists are, right? And then we just say list1.next, right? And then list 2. Similarly, in the opposite case, if this is false, we just get the opposite of it, right? So list2.next, right, is equal to list1, and then list2.next, right? And we need to return whatever value we have. So we know that we're modifying list1, so we're just going to return list1 here. And we know we're modifying list2, so we're going to return list2 here, right? And you can see how it'll work effectively, right? The lists are getting smaller and smaller in each iteration, either list 1 or list 2. And eventually, when one list runs out, we just use everything else of the remaining list and return it. So let's run it and see what happens, right? It's running, and we passed, and we've actually beat all the solutions. So this is relatively straightforward, but let's take a moment to analyze the time complexity and space complexity of this. So because we have to iterate through each list member at least once, we know that this is going to be O of n, because our m plus n, where m is the size of list 1 and n is the size of list 2, right? But the space complexity is actually also O of m and n, right? Because, or actually the shorter of the two, because what happens is that every time we call this recursive function, we actually take up memory in the function call stack. And this is going to be at least as long as however long the smaller of the two lists are, because you have to recurse that many times. Now there is actually a way to get the same speed, but with less memory, and that's actually using the iterative way. So let's try that next, right? So in the iterative way, we do something a little bit different. We create something called a dummy node, right? We'll say like our output is going to be some list node. And we're going to say, have a pointer to that output is going to be output pointer is going to be equal to output. Now, while neither of the lists are empty, or until we've sort of like reached the end of each list, we're going to keep going through them like we did before, except now we're going to do it in a loop. Right, and so again, if like the value of list 1 is less than the value of list 2, then we know that we have to use the value of list 1, right? So we just have the output pointer go to the value that's less, right? So we say output.next is equal to list 1, and then we'll just make list 1 a little bit smaller, right? And then vice versa, we'll do the same for list 2. So we'll just say output pointer dot next is equal to list 2, and then we'll say list 2 is equal to list 2 dot next. Simple enough, right? And then at the very end, we're just going to move our output pointer down a little bit, so that way we can repoint it at the next point as well, in the next iteration of the loop. Finally, this is going to keep going until one of the lists are pretty much empty, but the other lists might still have values. So we should just flush out the remaining data. So we'll do a output pointer.next is equal to, we'll check if like list 1 has values, and we can know that if it's like null or not, right? And if it is not null, then we know that list 1 is the one that's still full. Otherwise, we know that list 2 is the one that's still full. And because we've been incrementing these lists as we go through them, this is only going to have the remaining values inside that list. Finally, we have to get rid of our dummy node, and that's just as straightforward as going back to that original head we created, right? And just getting rid of the dummy node head, right? So now let's run this and see if that also works. Ew, did I mess up somewhere? Yes, I did not type this out properly. And there we go. Again, it is worked at pretty much the same speed as the recursive solution. However, because we're not adding any function call in the call stack, this actually takes up less memory than the old one. We're only creating memory for an output pointer, but besides that, everything else is in place. So in this scenario, the time complexity is O of n, and the space complexity is actually O of 1. With that said, I hope you learned something, and I hope you guys have good luck in interviews. Take care.